have gone through few many of the practices, right? Regarding static routing, default routing, and RIP. How about now? Is my voice audible now? Not clear. Come on. One second, one second. Let me make this happen because without my voice proper, I mean, now this guys, what you are telling? How about now? Is my voice audible now? No. Okay. Mm-hmm. Huh? How about now, guys? How about now? Still the same. Still the same. Okay. A little bit okay. Still the same. Okay. Hello. How about now, guys? Is it okay now? How come for few it's okay and few are not for everyone, the rest of them? Now tell me, is it okay? No. Can I am not audible? Proper is it not audible properly? Can I? You can
It's audible, Sanjay. Little disturbance is there. It's not very clear.
it's not very clear. Okay. How about now? Can I?
Yeah, you can talk. I think so.
Is it clear now?
Same as before. It is there. Little disturbance is there.
This disturbances are there still?
Not disturbance. Your voice is very low. Or
Very low. Okay. Change every all the default settings, everything. Why it's happening that? It's okay. Okay, guys. Might be some issue. Let me
whether
check.
my voice is audible?
Yeah, you are in
Is it
office,
clear?
right? You are in office or home?
Yeah, mine is clear, Sanjay.
No, no, no. Are you in office?
No, no, I'm at home.
Okay, I'm in office. I don't know what is the issue with the internet. Okay, guys. So I think it's better now, right? As of now, it's better. Better or good to go? Let's see. God. Yeah, I'll try to rejoin now. Okay, can I please give me the host control later after I'll just exit?
Sure, Sanjay.
Will rejoin. Okay.
Sure.
Yes, guys, I'm audible now. Is this the same? I'm audible. Still the same. But you're getting right what I'm talking, you're getting right.
It's better now, Sanjay. Yeah.
Okay, fine. I think let it get optimized. Fine. So I'll just go through the concept. Let us not stick on with the same thing again and again. Okay, fine. Okay. I think we are good to go. Yes, I hope so. There is a problem with the mic. I'll just report it to CCTV. See, I can't go back to RIP protocol again. If time permits, I'll go. Okay, Chetan. And also the video is given there. I've connected. I've tried everything, man. I've tried everything. Okay, tried everything. But I don't know what's the issue. Once again, give me a moment. I'll just connect to my hotspot. I'll just connect to my hotspot actually. Just give me a moment. How about now, guys? How about now? Yesterday I was taking the session from home, so it was okay. But I don't think so now. Now better, right? Yes. Yes. So yes, clear now? Okay. Fine. So now we'll just go with the session. Just go with the session now. Okay. Okay. Is my screen is visible, people? Yes. So for today, we will be discussing with this topic. So I'll just share a few things. Okay. One second. Got it? Yes. Open short is path first. With respect to its attribute, in the same. Yes, how about now, guys? How about now? Is it clear? Yes, thank you. Thank you. So, the next topic that we are going to deal with respect to dynamic routing, it's a dynamic routing protocol that is open shortest path first. I'll tell you what is it is all about, the open shortest path, what it is all about, and we will also discuss with attributes. Yes, how about now? How about now? The same. Okay. What I'll do is I'll just yes, guys, I'm audible now. I hope I'm audible now. Connected to with my phone as well. So let me disconnect this. Yeah, it's better, right? Yeah. I think the problem is with my laptop, right? Okay. I'll just check it. Let us rectify it. Buy new one. Okay. It's Infosys laptop. CCD want to provide me. Yes, exactly. Okay. Anyways, let us start. Let us start counting with this. Fine. I'll just share my screen quickly so that without any delay, we'll start it. Yes, tomorrow is holiday. Enjoy. Long weekend. Yes. So, the thing here is we are heading towards, is my screen is visible to everyone? Yes. So attributes, packet types, and adjacent states, single area and multi-area configuration, virtual link, authentication, and manual summarization. So these are the topics that we will be discussing for today's session. Is that clear, guys? Is the concept is clear? So this is the outline of today's session. So let us go with OSPF, what is OSPF is all about, and let us think about why we require this protocol. Is that clear? Let us have a chit chat. What is this protocol is all about? The name itself it is indicating, right? OSPF. Yes. Open shortest path first, so that when we run this protocol, only the minimal path should be considered. Is that clear? Only the minimal path between source and destination need to be considered. Is that clear?
Yes. Only the minimal path. Only the minimal path need to be accounted whenever this protocol is being added with the root summary. For the root summary, whenever this protocol is being added, we are supposed to take care of this protocol has a shortest distance identifier. A shortest distance identifier. Is that clear? Is the definition is clear? Yes. So now let us have a look over with. So what is the difference between the previous protocol and this protocol? Yes, of course, in the name itself it is mentioned, but I need to, yes. What is the difference? So in the difference, if I talk about the RIP, right? So the RIP is being accounted with only 15 numbers of hop count, right? But OSPF doesn't have any limitation. So it can go with unlimited hop count. Is that clear? Either OSPF or EIGRP, both the protocol can go ahead with unlimited hop count, whereas in the routing information protocol, the major disadvantage was only 15 hop limitations were being restricted. So that is the second point. Is that clear, guys? And the next point is, apart from routing table, so in the RIP configuration, it was able to configure only the routing table updates only with its neighbors, right? With its neighbor. Yes or no? With its neighbor, it was getting the updates of its routing table. But whereas in OSPF, along with the routing table update, it maintains a database. Is that clear? Is the concept is clear? Along with the routing table, it also maintains the database. So when we maintain the database, we'll be completely having the clearness of which is the maximum route and which is the minimal route. Yes or no? Yes or no, guys? Yes. So I'll just give you an example now. Fine. Router A, router B, router C, router D, router E, and router F. Think that A want to reach F. Clear? Think that A want to reach F. So now, what kind of scenario it is? It is a cyclic scenario, right? So all the dynamic routing protocols will follow the principle of cyclic scenario, and both cyclic and acyclic scenario. It satisfies everything. And also it will satisfy the property of classless and classful. Is that clear? Classful and classless. So now, which are the links? I mean, these are the links, right? So these are the link. Yes or no? From A to B and A to C, there is a link established. Is there any direct link that has been established to F? No, right? No. So that always OSPF is monitored based on the prerequisite of distance vector routing and link state routing. By having the prerequisite of distance vector routing, it will achieve a link state establishment between each and every neighbors. Is that clear, guys? So what is distance vector? Only the immediate connected neighbors are established with the link, right? But whereas in link state routing, each and every link state is established between the neighbors, and also their routing updates along with their database will be shared with their neighbors. Is that clear? So if I want to go with distance vector routing from A to F is accounted as what? Infinity. Yes or no? A to F is accounted as infinity. Right? So here on each and every link, a metric or cost will be dedicated. Is that clear, guys? A metric or cost will be dedicated. For example, I'll just take this route something like this: 5, 6, 2, and 3. So there is a link here as well. Between E and D, there is a link. Okay. So based on the cost, So A has got n number of routes, right? Yes or no? A has got n number of routes to reach F. Yes or no? It has got a backup plan as well, right? It has got a backup plan. If this route is failing, it has got the other route that can navigate with. Yes, guys. For example, it's a full mesh. It's a full mesh topology. It's a full mesh topology. For example, I'll take something like that. Yes. You studied about topologies, na? You have studied about topologies. It's a full mesh. So now this link is being completely down. Of course, the cost of this link is very low. But as the link is completely down, C will immediately update its routing table to A or B. Tell me. C will update its routing table to A or B. It will update to B, right? So some or the other way, A will get the update of C, right? Yes or no, guys? Some or the other way, A will get the update of C or no? Because C is trying to share its database with B. Of course, B will also share its database with A. So thereby, by having the entry of B's database, A will look the B's database, right? A will look into the B's database. In the entry of B's database, it will also check whether C is there or not, right? Okay, fine. I have got the way to reach C. It will identify the way to reach C. So how? A, B, C. Earlier it was directly attached. It was the immediate neighbor. Due to the link failure, it was not able to reach C. Yes or no? So first of all, it will consider which is the shortest path to reach the destination. That is the first criterion. After that criterion, if anything happens between the network, so thereby A will try to reach from A to B and B to C. Yes or no, guys? And thereby it will follow the minimal distance. For example, 2 plus 5, 7. 7 plus 6, 13, right? Now, 7 plus 6, 13 to reach the destination. And 2 plus 3, 5. 5 plus 2, 5 plus 7, 12. 12 plus 2, 14. So this is the maximum route, right? A, B, C, E, F is the maximum route. So we are not ready to take this route because the cost value of this route is very higher when compared to this route. And also the hop count is also very higher when compared to this route, right? In this route, to reach destination, it has got only 2 hops. But whereas to reach the destination from this route, A, B, C, E, F, it has got 3 hops. Yes or no? It has got 3 hops. So it will choose the shortest distance in case of failure also. In case of failure, what should the neighboring node should act as? It will share the database between the condition. Between its neighbor, immediate neighbor. Is that C will share the database information only with B? With whom it will share then? Other than B, it will also share with E. Exactly. So thereby E will also get to know how A is trying to reach F. Yes or no? Got the point, guys? E will also come to know how A is trying to reach the F. So thereby, don't you think that there is an homogeneity in it? Homogeneity with respect to all the routers? Yes or no? There is an homogeneity with respect to all the routers, right? So all the routers are getting completely converged within a minimal span of time, right? Yes or no, guys? All the routers are getting converged within a minimal span of time. Whereas in RIP, only the immediate neighbors will get updated. Every neighbors will be shared. Yes, of course, every node's neighbors, so that A will be having the complete information of the entire topology with minimal convergence time. Is that clear? Is that clear, guys? With the minimal convergence time, the router A will be having the complete topologies. Likewise, B will also be having the same thing as A did, and also C, and also E, D, and also F. Is the concept is clear? How it is overcoming with respect to the convergence time and also with respect to the minimal cost value? Yes. So now let us go ahead with the concept. I think introduction to OSPF. Are you not able to view the screen? Showing blank or what? It's throwing the error. 1 second. Oh, 1 second, guys. It's not showing. Okay. Just check at your end. Is Lexis opening or not? Please check at your end. Is Lexis opening or not? For me, it's giving some error. Opening. Lexis opened. Okay. Can you share me that link? Whichever the link that you have opened with in the chat box, can you please share it? Yeah, try FA. Yes, that is what I'm looking with. Here. Okay, is my screen is visible? I clicked it, but it's not opening. I think someone has cursed me today. Someone has cursed me today. I don't know. So many issues. Yeah. Okay. Yes, Lex FP, it's working. Yeah, I'll just go with this scenario. Yes, as I told, so there will be least convergence time that occurs in between the entire topology, right? As per the topology that we saw, there will be a least convergence time. Yes, right? Yes. Next, attributes. So what are the key attributes? Link state routing protocol. So OSPF is a type of link state routing protocol. So what is this link state? That is the link that is established, and it tells about the condition of the state of the nodes between their neighbors. So that is what the link state routing protocol actually does with. Yes. Curse is gone now. It's okay. With all your wishes, curse is gone now. Okay. So cost is calculated, right? Cost is calculated. So how it is calculated? Based on bandwidth divided by interface bandwidth. So the bandwidth is nothing but Yes, guys, sorry. Some facilities team was here with having, I raised a complaint with respect to internet. I'm really sorry. Okay. I just muted. Yes. Okay. Yes. So the link state, it will update what is this actual status of the link that is existing between their neighbors. And accordingly, the database will be updated. The database will be updated. Is that clear? The database will be updated. And next, cost is calculated reference bandwidth. Bandwidth is like the rate of data which is entering with respect to the frequency. With respect to the frequency. So let us not go with the perspective of bandwidth into much deeper time. So bandwidth is associated with what? Frequency divided by time, right? So the total frequency along with the time. So you will evaluate what is the bandwidth is all about, right? And interface bandwidth is nothing but the physical interface that has been attached between each and every link. The physical interface that is attached between each and every link. So the cost will be evaluated in such a way. So there may be conditions of default cost. There may be conditions of default cost, or there may be a condition of updated cost with respect to the shareable routing updates. The shareable routing updates. Is that clear? The shareable routing updates. I'll give some short write-ups here. Please try to catch up that. Okay. Reference bandwidth is considered as 100 Mbps. So never we will take below 100 Mbps. Always we will go with 100 Mbps. Of course, either we will choose with fast Ethernet, or either we'll choose with gigabit Ethernet. Is that clear? More than 100. 100 will be the minimal bandwidth. Am I audible to you all, guys? Am I audible to you all? Yes. So next year, no periodic updates are sent. No periodic updates are sent. So what is that periodic updates? So we came to see that there was 30 seconds, right? Some keyword in RIP. Yes or no? There was some 30 seconds, right? So what is this 30 second? It was giving a periodic update. So until and unless every router gets updates with its immediate neighbor, the entire topology will not get update completely. Is that clear? Is it clear? Is it clear, guys? See, for example, router A is aware of router C and B. So till now, P is not been updated, but A and C is been updated with its routing table. But C will be having also, it will be having the communication with E as well, right? C is also having the communication with E as well. Yes or no? C is having one more neighbor, right? Yes or no, guys? Yes. C is having one more neighbor. So he also shared the information with the C, but C will wait until the acknowledgement is released by A, so that the complete table of A should get updated until it share the database, its updated database when it is being shared by E. Is that clear? Is the concept is clear? Yes. Is the concept is clear? Yes. So that is what the no periodic update are sent then and there. So it will wait for entire topology and it will update it. So what were you doing, Muthu Krishnan? How many times to repeat it? That was the repetition I gave. Someone asked for repeat it, right? I gave the repetition. Yes. Okay, fine. So A, B, C are directly connected, right? Now A will get updates from C, and A will also get updates from B. But there will be update from E as well to C, right? Yes or no? So according to the rule, A should be having the knowledge of E as well in its topology. Yes or no? In its database, A should be having the knowledge of E. So until and unless each and every neighbor share their immediate information, the entire topology will not send the periodic updates then and there. Then and there. Is that clear? Yes. Next, the AD value is 110. When we configure it, you will witness it. How the AD value is being calculated there. Next, terminologies. These are the main important terminologies that you should be aware of while you are working on your hands-on. Is that clear, guys? Is that clear? Yes. Neighbor. We know what is neighbor, which is directly connected. Yes or no? Which is directly connected. So, which is indicated by C. The neighbor is indicated by C. In the simulation kit, it is indicated by C. And again, router ID, of course, the IP address. Of course, the IP address of that respective interface that we have seen in many demonstrations that we have come across with. And again, link state advertisement. Link state advertisement, which means each and every router are supposed to send the link state advertisement to their immediate neighbors to identify what? To identify the shortest distance. To identify the shortest distance. And again, area. I'll talk about area later after. I'll talk about area later after. Don't worry about area as of now. Please pause this area because we have got a different section for area to discuss with. Okay, I'll discuss immediately after taking a couple of minutes. I'll discuss with area. Yes, designated router, a router elected by all the routers in a LAN to represent all other routers so that it acts as a leader. Is that clear, guys? It acts as a leader. But this designated router should be always present in a default area. It should be present in a default area. I'll tell you what our areas is all about. Okay, it should be present in default area. So it should not be present in the customized area. Is that clear? It should be always present in the default area. Am I audible to you guys? Yes. Next, backup designated router. Of course, if this is getting failed, there will be a backup designated router. There will be a backup designated router. And again, adjacency, list of all neighbors to which router has established a bidirectional communication so that it is completely full duplex. This OSPF protocol is completely full duplex. Is that clear, guys? Because it has to share its database information with its neighbors, right? So whatever the changes that are taking place, immediately it has to share with the neighbor. Yes or no? Yes. So that is what the important criterion. So these are the important terminologies. I think you are aware of these terminologies as of now. Fine. The important protocol messages. It has got wide protocol messages. But here, unlike RIP, OSPF does not carry data via either TCP or UDP. RIP used what? Which was the protocol it used? It used UDP, right? Even though it is full duplex, it is not trying to use TCP as well. Even though it is full duplex, it is not trying to use TCP. Because if any of the link fail, what is TCP definition? The definition of TCP is what? The path is defined. Yes or no? The path is defined. For example, in the instance A, B and C, if this fails, what happens? Of course, we'll treat that it is following TCP now. It is following TCP now. If the link is failed, what happens? It will immediately take up the backup plan, right? It will immediately take up the backup plan. Yes or no? Yes. So thereby there can't be deployment of TCP at all because as it has got some other variants to deal with. Is that clear? When TCP is established, it has been reserved. So it can't reach with either of the path. The path is completely reserved there. It can't reach apart from TCP path. It can't reach with any of the path. What happens if the link fails? So there won't be any communication at all between the neighbors and there won't be any exchange of database at all. Is that clear, guys? So for that reason, it will not use any of the TCP or UDP protocol. See, TCP is nothing but what? What you have understood about TCP? Think that it is a weekend and you want to book a table in the restaurant. Is that clear? Is that clear? Now what happens? At 6 p.m. between 6 p.m. to 8 p.m. your table is reserved and you are taking your family to the restaurant. Is that clear? And you are arriving to the restaurant at 7:55 p.m. So between this time, more than 1.5 hours, it was completely unutilized, right? It was completely unutilized. Yes or no? Yes or no, guys? It was completely unutilized. The same thing happens here. Your OSPF is completely dependent on what? Bandwidth, right? So if the resource is not being utilized at all, what happens? We can treat it as unutilized. So there will be unutilization of the bandwidth when we are using TCP. Yes, the loss takes place, right? Of course you will reach, and within the stipulated time you will use that table. But till that time, it has not been kept for anyone else, right? The path is open and it has been completely underutilized. Is that clear, guys? Is that clear? So why we are not using TCP here? It is also one of the other scenario. Is the concept is clear? Yeah, to avoid loss. Because the OSPF is completely dependent on interface bandwidth and also the topology's bandwidth. Is that clear? After 8, there won't be any reservation at all. After 8, there won't be any reservation at all. So you will enter, and after 8, whether you are dining at 8 o'clock immediately or whether you are dining at 9 o'clock, you will not be aware. Are you getting clear? Yes. So that is how it works. Exactly. Next, hello messages are exchanged between the neighbors. Is that clear? Hello messages are exchanged between the neighbors. So this is one of the protocol message that has been exchanged only between the neighbors. So the database description contains the entry of all the database relative to the routers, neighbors, whether they are existing or not in that topology. Is that clear? Next one is link state request. So there would be link state request with the neighbor, OSPF neighbor. So in the previous scenario, we came to know that R1 was configured with RIP, right? R1 was configured with RIP. But until and unless its neighbor got updated with the RIP message, it was not able to communicate with the RIP route, right? Yes or no? Yes. The same thing happens here. That is, the link state request need to be updated with its OSPF neighbors only. Only with its OSPF neighbors only. If the immediate neighbors are not being updated with the OSPF neighbors, then the request can't be successful. Yes. The next one is update. It is nothing but reply, vice versa. And next one is link state acknowledgement. Of course, you need to have an acknowledgement for each and every process within what? Round trip time. Within a particular round trip time. What is round trip time? So the sender and the receiver, for example, sender and receiver will be enabled with a particular RTT time. Right? So within the stipulated time, if it is not giving an acknowledgement, immediately it will send the next information. So what happens here at the receiver end, it will be waiting whether it has received the acknowledgement or not. Whether it has received the acknowledgement or not. If it is not identifying the acknowledgement, so what happens? It leads to unreliable transmission. Is that clear? Is the concept is clear? So that is why link state acknowledgements. So what is link state? The connectivity between the neighbors. Yes or no? So there should be mutual acknowledgements that need to be exchanged between the neighbors. So then only the periodic updates will be done on the entire topology. Is that clear, guys? RTT is set for the sending side and receiving side. For example, if I tell you that you will be having a lunch at 1 o'clock, immediately you will start asking me, right? If I am not leaving at 1:05, immediately you will be asking me, right? Yes or no? So lunch break. So you can relate that. So within that stipulated time, you will not be able to communicate with the nodes. Exactly. Okay. Okay. Shall we see with OSPF configuration now? Shall we see with OSPF configuration? Okay, good to go. Before that, I'll give the scenario of same thing it is described. Don't worry, same thing it is described here. You can just go with the next part later after areas. Okay. Say when we want to talk about areas, there is two types. One is default, and the other one is customized. Is that clear? One is default and customized. Default is always declared with area, and with respect to area ID. Always it is declared with 0. Is that clear? Default area is always declared with area 0. Are you getting it? Yes. So for this default area, at least one DR should be there. That is designated router should be attached. What is designated router? Which represents the entire topology. The designated router represents entire topology. Yes, it acts as a leader. Can you see this figure now? What is this? It is a layout of OSPF network. You can also treat it as one single autonomous system. Yes, you can treat it as one single autonomous system. So it is a OSPF network, so that in this network, each and every internal router are configured with OSPF database. Is that clear, guys? In this OSPF network, each and every router are configured with OSPF database. And what is ABR? Area Border Router. What is area border router? Area border router are always located internally. Yeah, each router has its own database. Exactly. Each router has its own individual database. So for each and every OSPF network, there will be an internal situated of area border router. Area border router will be existing. So can you see here normal area which is being set as with some other area ID? Can you see here area 51? Area 51? Yes or no? Yes. So this area border router will also act as a designated router because it is mutual for both the areas. Can you see here? It is called as backbone area or default area. Always default area will be represented with area 0. Is that clear? So this is one autonomous system which is completely configured with OSPF network, and this autonomous system, if it want to communicate with the external network, are you getting clear? if it want to get communicate with external network, whether that network has got OSPF configured or non-OSPF configured or non-OSPF configured. So thereby it need to get attached only with area 0. Is that clear? So it should not be attached with any of the other areas. Is that clear? Yeah, it should be related to area 0. So if it is not completely related to area 0, at least a router which is representing under area 0 should be related to the external network. Then only that autonomous system will be able to connect with the multiple OSPF networks or multiple non-OSPF networks. Is that clear? Is that clear? What is area is all about? Yes? Do you want me to repeat about area now? Do you want me to repeat again with respect to area? Yes. See, there will be one single autonomous system, guys. This is one single autonomous system. So in this single autonomous system, there will be an OSPF network. When can I call a OSPF network? When all the internal routers are being designed for OSPF protocol. When all the routers have been designed for OSPF protocol. So here there can be one single area. If there is only one single area, immediately we can treat it as something like this default area. So what is the default area? This one. The default area is nothing but the backbone area itself. Always it will be represented with 0. But in this scenario, we got two areas, right? But in this scenario, we got two areas. So area 51 with one ID and area 0, which is default. Of course, there should be at least one default area. Whenever a autonomous system need to get communicated with a OSPF network, there should be at least one OSPF area. Is that clear, guys? Is the concept is clear? Yes. Now, between these areas, there will be a designated router. Which is called as area border router. Are you getting it? Area border router. You can treat it something like this. Our India and the borderline. Some other country. Designated routers are internal state boundaries. Which deals with couple of areas, couple of states. Is that clear? Yeah. So there is the border on China. So it is what? Interacting of external network, right? China is our external, right? China is not internal. China is completely external. So to deal with that, we need autonomous system boundary router. So this router should be attached to the default area. Is that clear? This router should be attached to the default area. If it is not at all completely attached, to area 0, at least it should get attached with one of the router, which is being attached to area 0. Is that clear? Is that clear? Yes. So thereby we are not worried, right? What China is eating, what they are doing, we are not worried, right? We are worried about only our country's economy. Yes or no? So whenever OSPF is being instated, so tax fixation is completely for everyone, right? Yes or no? Common. Whether it is anyone, the tax fixation is common to everyone. Yes, but in China, the tax rules may be different. But we don't know whether they are using the same impose of our tax imposition or not. Yes or no? We have to worry because like coronavirus is mutual for everyone. Yes. Okay. So you got the knowledge of area, right? Now you got the knowledge of area, right? Yes. So let us configure one simple topology. Once again, I'll just share my screen immediately. I'll just open this tool. Is my tool is visible, people? Is my tool is visible? Yes. I'll go with single area now. OSPF single. OSPF single. Okay. Yeah. So treat it as very basic configuration. Treat it as very basic configuration. I'll take only 2 routers. So this is very interesting protocol. Very interesting dynamic routing protocol. Clear? So what I'm trying to communicate here is, so this is area 0. Of course, if no area is customized or any name is not given, immediately you need to treat that it is a default area. It is a backbone area. So it's a simple configuration what we are trying to do here. Is that clear, guys? Area 0. Exactly. So between this guy and this guy, I'll communicate. Okay. Yes. Exactly. So think that there is one network. There is one network which is led by 172.16.10.0. This is one network. So there is only one network, right? As per the configuration, it is only one network. ABC, yeah. So between the interfaces. So there are only 2 interfaces, right? There are only 2 interfaces. Exactly, na? Yes, guys? Okay, fine. So let me configure this. Let me configure this. Do you want me to use the notepad? Okay, let me use it. OSPF simple. So for R1, so we know this, let us not go with again and again. So assigning of IP address, IP add. So which is the network we have taken? 172.16.10.1 I'll take, 10.1 I'll take, and I'll represent it with classless. Is it classless or not? Agreed? Classless or not? Yes, guys? Yes, classless, na? Yes. No shut dub. Do WR. Do WR. So exit. Yeah. Exit or anything is fine. So it is good practice. Give exit itself. Okay. So go back and okay, start the topology. Okay. Show IP interface brief and show IP router. Okay, so there is a directly connected network. Okay, fine. It is established with, and it is classless. So thereby when we are configuring with OSPF, dynamic routing always supports classless. Okay, next. So what should be the next configuration, guys? What is the next configuration? R2. Sorry. Yeah, R2. It is for R2 configuration. So let us go with R2. So can I take something like this in easier way? Okay. Configured? Yes. Okay. Oh, which is the router I've taken? R1 itself. Oh, okay. One second. By mistake I did it. Show IP interface brief. Okay. Go to R2 here. To show IP interface brief. Okay, if I can check here, do ping 172.16.0.10.1. Okay, so it is directly connected and it is acceptable. Fine. So we are getting the reply from these two nodes. So to configure OSPF. No, I'm not taking any end user devices here. I'm not taking any end user devices. You can experiment. Okay, to configure OSPF, so we got the standard evaluation that need to be done on router. OSPF at router. OSPF at router. So what is that configuration that we need to take care with? Router OSPF with OSPF ID, process ID. We call it as process ID. Is that clear, guys? Router OSPF process ID. Then router, and for example, okay, router OSPF process ID we gave. Network with which is the network we are connected with? Which is the network we are connected with? 172.16.10.0, right? So this is the network. And here while providing the subnet mask, are you getting clear, guys? While providing the subnet mask, instead of subnet mask, we will provide the wildcard entry. We'll provide the wildcard entry. It is wildcard. It is called as wildcard mask. It is called as wildcard mask. Is that clear? It is called as wildcard mask. So in this wildcard mask, how we will provide? We'll provide something like this: 0.0.0.255. So instead of 255, I placed with zeros, and at the last I am placing with 255. So it gives a reverse value of host bits. That's it. It gives the reverse value of host bits along with the network bits. That's it. Please take care of it. It gives the reverse value of host bits along with the network bits. That's it. Next one is area space 0. So which is the area we are given here? Area 0, right? Yes or no? Yeah, default area should be given. Exactly. And exit. So shall we configure the same thing in R1 now? Shall we configure the same thing in R1? Yes. Okay. We have done it, and we'll just check to show IP route. So is that OSPF protocol is enabled now? No, right? Because it, why? What is the reason? Or R1. What is the reason? Yeah, the neighbor need to be updated. Yes, exactly. The neighbor need to be updated. So the same thing for R2 also I'll take care of. For R2 also I'll take care of, but I'll change the ID. Is that clear? But I'll change the ID. Process ID will be changed. Yeah, OSPF process ID will be changed for R2, and I'll configure accordingly. Is the concept is clear, guys? Is the concept is clear? Yes. Next, do show IP route. It's directly connected, na? It's directly connected. 1 second. Okay, I've given the OSPF network, but it is not sharing the table. Why? Why? Because it is directly connected. So even though I'm providing the OSPF network, okay, let me put something like this: to show OSPF neighbor. Where it is giving? Yeah, it should display this one. It should display this one. But as we have taken only one default area, it is not displaying it. Because these two are connected. These two are connected to each other. So as it is directly connected, so it is not displaying. So now what we'll do is, we'll stop this. We'll stop this and we'll attach one more. We'll attach one more router. Is that clear, guys? We'll attach one more router. Clear? Okay. So for this router, I'll just state it as, okay, I'll just write here. For R3, okay, sorry. How about now? Is my voice audible now? Yes. Router OSPF3 network. So which is the network 192.168.10.0, 0.0.0.255, and area I'll give it as 1. I'll just represent this area as 1 now. I'll just represent this area as 1. So it can be from 0 to 255, any representation, no issues. Okay, and exit. Now I think we need to configure the same thing with respect to R1 as well. Yes, the same thing to be configured in R1. Conf T interface F0/1 IP address 192.168.10.2 255.255.255.0. Exactly. No shut exit do WR. exit, do WR. And here again, enter into router OSPF. What is the process ID? 1. Already we have given, but again let us give for our simplification 116.10.0.0.255. What is the area ID? Area ID should be what? 1 or 0? We are in R1. It should be 0 exactly. So next, let us take it as 192. 192. And again, 192 belongs to which area? Area 1 or area 0? Area 1, exactly. So exit. Exit. Do WR. Now do show IP route. Let us check with all the possible routes now. Can you see here? Again, it is connected to this area, right? So it is not popping up with which one? It is not popping up with the other area. Let me check from R2 now. Let me check from R2 now. Show IP route. So it is also not popping up with the area. So what is the issue? What is the issue? One second. So this is area 1. Yeah, I'll give that one. But route OSPF. So it's not providing any entry of OSPF here. Is that clear? It's not providing any entry of OSPF. Now what I do is, I'll just make sure not give entry here. Area 1 is FA0/1. Yeah, process ID we have given. Process ID we have given for R2. Here also we gave R3 for here process ID is different. Na? We gave it. Okay. Do show IP route OSPF. That's it. Yes. Can you see here? From R3, because as they are in one area, it is not identifying. For to reach 10.2, which is 10.2? Which is 10.2? Yes, guys. Which is 10.2? Yeah, FA, no. Which is 10.2? This one, right? Yes, R2 is 10.2, right? Sorry, R1, FA0/1 is 10.2. So here, when I provide, I'll just provide the complete route from the other area. Can you see here? So what type of area is created now? What type of area is created, guys? So only inter area is created. Can you see here? OSPF inter area is created. Yes or no? Yes, exactly. OSPF inter area is created in between. Yes, exactly. Got it? So that this area is directly connected and it is the default area. So which one will be the designated router now? Tell me, which one will be the designated router? There was a delay. That is why it didn't happen. Yes. R1 will be the designated router. So R1 is the one which is representing the default area with a customized area. Is that clear? Is the concept is clear? Yes. Exactly. Exactly the same. Yes. Okay. Now let us also try to configure something like this. Let us involve. Once again, give me a moment. Am I audible to you guys? Yes. Once again, give me a moment. Before the break, we'll configure one more assignment on it. Right? I'll just close this because there will be a lot of. Okay. I'll also configure once again. I'll also configure, as I told, we missed it, right? Loop back. We'll also configure the loop back. So for loop back at R3 in the global configuration mode, provide int L0. I'll take it as loopback 0. You can take anything. Audible. Guys, am I audible or not? Yes. So I'm providing the loop back here. So that is loop back 0. L0 is nothing but the loop back. L0 is nothing but the loop back. And here I'll add IP add. IP add. Can you see here? Interface loopback 0 is enabled. Can you see here? Yes. I'll just add one address. So what should be the subnet mask? What should be the subnet mask? 255.255.255.255. Yes. Okay. So you no requirement of no shut. Already the state is up because it's a virtual interface. It's a virtual interface. Is that clear, guys? Now provide do show IP interface brief. Can you see here? One more loopback interface. Was that the physical interface? No, right? It was not the physical interface. It was the virtual interface. It is not the physical interface that we added externally. We created it logically over the virtual network. Is that clear? So whenever, for example, R3 we have created the loopback. So it is not necessary that the neighbor should also be having a loopback. Not required. Okay. R1 from R1 do ping. From R1 do ping the loopback. It's not pinging. Okay, I think we need to troubleshoot it. Fine, a few times. Okay, wait. Let me check what is R1's IP address. Okay, fine. Do ping. So let us ping that interface 192.168.10.1. Let us ping it here. Okay, so it is taking, but loopback. Let me check. Let me check with R1. Oh, sorry, R3. We need to ping the loopback. Do ping 1.1.1.1. Okay, we are getting the success rate, right? No shut is required. No shut is required. We are getting the success rate within the self. We will be able to loop it back. Exactly. Then see, this is the metric. So this is the metric that is evaluated with respect to bandwidth, by default bandwidth. And again, what is Loopback, that is what? It creates the virtual interface for troubleshooting activities to check the liveliness of that interface. Is that clear? Now, administrative distance. This is 110 is administrative distance. Is that clear? 110 is nothing but the administrative distance. Loopback, how I added? Okay, once again, loopback I configured on R3. So these are the command R3 conf t interface L0. It can be L1, L0, whatever. They will provide you in the assessment. In the hands-on assessment, they will provide which should be the loopback number. Okay, L0, L1, whatever it is. Then IP address 1.1.1.1. So the next one and the rest of the mask ID will be something like this. Don't provide any no shut command. Don't provide any no shut command. Is that clear? Yes, if the interface is shut, the loopback will work. It acts like a troubleshooting activeness for that particular node. Is that clear? For only that particular node, it acts as a troubleshooting activity. IP will not be fixed. I mean, it is not required. It's not required exactly. L0 is nothing but loopback interface number. Loop is what? Within self, right? Within self. So it is a self ID that is being self ID IP address that is being given to that particular node. That's it. Clear? Okay. Okay. I think let us go for a break now. Let us go for a break. After coming from break, we'll go with multi-area configuration. So this was with single configuration. Let us go with multiple area configuration.
Yes, guys, am I audible to you all? Guys, am I audible to you all? Yes. Is it working now? Is my voice is clear? Okay. Fine. Let us look at OSPF multi-area. Is that clear? So we configured with one single area and we attached one area now. So let us configure with multi-area configuration now. Quickly, I'll share my screen. Yes. Could you see here? Multi-area configuration. I'll take Lex example. Yes, I'll take Lex example. Okay. That Lex example. Yeah. Shall we take this example? Yes, guys. We'll take this example. Okay. Okay. I think for your batch is the first batch. I am giving all these next examples for these fundamentals of routing. We used to configure with different scenarios. Okay, fine. As per your demand, I will take Lex example. Okay. Voice is not clear. Okay, 1 second. I'll just connect to my phone. One second. Give me a moment. Give me a moment. Am I audible to you? Yes, thank you, guys. Thank you. Yes. So we are taking the example of the Lex demonstration itself, and we'll quickly do this because we are left out with so many other topics are there. When the virtual link is there, apart from this, and also authentication is there. So we need to complete that by 4 o'clock. So let us go with quick reactions. Okay. So what we do is we'll just open GNS3. We'll just close this configuration of single area configuration. Clear? We'll just close this and we'll just go with multi-area. GNS3. Yes, GNS3. Okay, are you able to see this? Okay, now please tell me how many routers are there, guys? Because let us not switch to screens. How many routers are there? Have you opened it? 5 routers are there, right? Yes, 1 second. 5 routers are there. 1 second. OSPF. Okay, OSPF multi for network. Okay, so according to you, 5 routers are there, right? Okay, 5 routers. Is that done? Is it clear? Yeah, 5 routers. Now tell me, so which routers are in series? R1, R2 and R3. R1, R2 and R3. Okay, fine. Clear? Fine. R1, R2 and R3. Exactly. Now, R5 and R4. Accordingly, I have placed. Fine. So now what we'll do is we'll just create the link establishment between these. Clear?
Okay. I think all the interfaces are even. Is that absolute, guys? Is that absolute? Are you able to view it? Yes, thank you. Thank you. Okay. Now, what we do is we'll just go accordingly. We'll just open the notepad. So how many interfaces for R1? So for each and every router, there are two interfaces, right? For each and every router, there are two interfaces. Let us go with the example of this Lex itself. So area 100, area 51, area 0. So multi-area. Yes, exactly. It is a multi-area. So this is area 100, right? Area 100. And this is area 51, if I'm not wrong. Okay. Duplicate. And this is area 0. So there is a backup area. So this is the backup area. Is that clear, guys? This is the backup area. Good to go. Yes. Fine. So now what we'll do is we'll just configure this accordingly. And yes. So this is one area, right? So this is one complete area. According to the scenario, this is one complete area. So till here. No? Okay, okay. One second. I'm doing it. Please be patient. So once it is done, we can deal with that. Okay, fine. I'll just give some colors. Okay. Okay. And style, it is dotted, dash dot. Okay. I've given this area and lower. Okay. So this is one area, right? So that R2, R1, R4. Okay. I'll just make a note here. R1, R2, R3, R1, R3 belongs to which area? Belongs to 100. Is it clear? Yes, it belongs to 100. So let us go with this now. Yeah. And this area, it is 51. Yes, exactly. It is 51. So we'll do one thing. Style. I'll just go with some other dark colors of green. And okay. And it is dash dot. Apply. Okay. Lower. Fine. Yes, guys. Are we good to go? Yes. So can you please help me out? Which are the routers? R2, R3. Sorry, here we made a mistake. It is R4 exactly. Okay, it is R3 and R5. R5. So it is belonging to which area? It belongs to which area, guys? It belongs to 51 exactly. So only two routers, that is R4, R5 belongs to 0. Clear? Clear. Yes. I'll just plot that. Yeah, I'll just plot it. Fine. Style, and I'll just put one more color on this. Just put pink. Is it clear? Yes. Got it? Yes. So how many areas are there? 3 areas are there. So based on 3 areas, we have allocated the routers, right? We allocated the routers. Is this the same architecture we are finding here? Yes. So 70, 60, 11, 90, 80. Fine. So this belongs to 70 network, and this belongs to 60 network. This belongs to 60 network, and this belongs to 11 network. This belongs to 90 network. This belongs to 80 network. Exactly. All are classless. I think so, right? Okay. 70, 60, 11, 90, and 80. Yeah, good to go. Okay, good. I recall the networks. Yes, good to go with the configuration now. So this is 70 network, 16 network, 11 network, 90 network, and 80 network. Yes. Okay, the setup is done. So what we are trying to do here is configure multi-area. Configure multi-area. Multi-area OSPF. Is that clear, guys? Now tell me R1. R1 is it? R1. Am I audible to you, guys? Repeatedly, I need to ask, or else it will slip off. Okay. R1 we shall take. For R1, now tell me for R1. Tell me for R1. So which are the interface? Which are the networks? Conf T. Next interface. So which are the interfaces, guys? F0 bar 0, F0 bar 1. F0 bar 0, which is IP address 70.0.0.1. I'll take 255.255.255.0. Is that clear? Okay. So this is done. No shut, and WR. Okay. So again, one more interface I need to configure, right? That is interface F0 bar 1, IP at, which is 80, if I'm not wrong. Is it 80? Just check it, guys, if you are looking with the next part. Okay, fine. So no shut and WR. No shut and WR. Here itself, I'll configure the OSPF. So let us not wait. Okay, are we good to go? Here itself, I'll configure the OSPF. Yes, guys. Okay. So what is this? Conf T router OSPF 1. I'll give process ID as 1. Network. So 70.0.0.0, 0.0.0.255. Area will be 100. It belongs to area 100, right? Yes. Next, network 80.0.0.0, 0.0.0.255, area 100. So both the interfaces belongs to the same area. Both the network address belongs to same area. Agreed? Agreed, guys? Okay, NWR. Fine. So what we do, we'll just go to router. Okay, we have not started it. Okay, I think it is started now. Let us wait for a while. Okay, show IP route. It is taking M router. Okay, only directly connected networks are attached here. Fine, good to go. Router R1 is configured. Okay. What we'll do is we'll just copy this. And we'll design it for R2. Sorry, R2 router. And we'll make some changes here. FA0 bar 0 of R2. It belongs to 70 network. Exactly, but address should be changed. So that is done. FA0 bar 1 belongs to 60 network and it need to be changed. And this will be, ID will be 2. and 70 remains the same with area 100, but 60 and I think area will be changed, right? 51. Yes, area will be 51. Yes. So good to go with R2 as well. You need to practice, guys. If you are not practicing, it will not come. Okay. Ensure that you are practicing. Clear? Right. So R2 is done. R2 is done. Let us go back to R3. R3 and we'll configure accordingly. So here R3 should be taken care. R3. Okay, so R3 FAC bar 0 bar 0, where it is connected to? 60 and 11. 60. Okay, it remains the same. And here FA 0 bar 1, it is connected to 11. Let it remain the same. So here it becomes 11 and remaining are same. Okay, it is 51 and also here 11 also belongs to 51. So this is changed. Clear, guys? Clear with the configuration? Whatever the changes I'm doing, are you getting it? So area wise, I'm changing it. Are you getting cleared? Okay. Show IP root. I'll just check it. Okay. It's clear. Next. With respect to R5. So this is router 5. This is router 5. I'll just go with router 5 now. R5. Okay. So what are the changes? FA 0 bar 0 belongs to 11. So this should be 11 and remaining are same. And I think this should be 90. And for 11 it is 51 and for 90 it should be 0. And here I'll change 90. Is that clear? Yes, Chetan. ID, right? ID. Yes. Thank God. ID. We didn't change ID. So this is where I'll do mistakes. People, please take care of these mistakes as well. Okay, I'll just change this for 5. And for this, it is router 3. Yeah, last time not changed. Yeah, I'll do it. Right now I'll do it. For R3. Show IP root. Okay, it directly connected networks are displaying. Okay. For R2 also, the same thing I did it, the same mistake. Let me check for R2. Okay, it is updated with this database. Once again, let me come back to this later on. Okay. So for R5, we were doing the configurations now. For R5, we were doing the configurations. Also, okay, it is taken care. Okay. Let us go with R5. Area 0. Exactly. Show IP. And come back to R4. So now let us come back to R4 and we'll place, first of all, we'll place this, and FA 0 bar 0 is belonging to which network? 90. Okay, 0 bar 1, it belongs to 80, and this should be because already R1 has taken that dot 1. So this is okay, 80 and okay. 80 and 90, and this should be what? 100. Yes, no? Yes or no? That should be 100, right? Yes. Okay. Good. Let us go for R4. Okay. Show IP root OSPF. No OSPF is configured. Why? We gave it now. Show IP root. Why it is not taking? Okay. Okay. Can you see here? Are you able to see? The OSPF is configured and all the possible routes are displayed. Okay, let me check from R1 and let us go back to demo. So whether we have done the right configuration or not. So this is the configuration, right? We took care. Yes, guys, this is the configuration that we have made. And we enabled all the interfaces with respect to those terminals, right? Those terminals, we have enabled all the interfaces. So R1 belong to 70 and 80. This holds good. This is done. Just give me a thumbs up if it is done. Yes. Next, show IP interface brief. Okay, fine. If you are looking with 60 dot, okay. For R2, it is 60 and 70. Exactly. Okay, all these 90 and 11. Exactly. To configure OSPF in R1 and advertise the networks. So what is that? For R1 area, we gave the right area, right? Because it was belonging to 100 itself. R1. See, it all happens at interface level, guys. Because see, can you see here? R2 interface is F0 bar 0 and F0 bar 1. Both the interface areas are not similar, right? Both the interface areas are not similar. And there is a backbone area which is attached to each area. Yes or no? Yes or no? If the backbone area, at least one router is attached, na? At least one router is attached to the other areas, na? So it is not necessary or mandated that each and every router should get connected with all the areas. So it is with respect to the default area that at least. So how many designated routers are here? How many designated routers are here? Area 2 designated, right? One is R4 and R5 because both are having the connectivity between multiple areas. Yes or no? So this is completely one autonomous system, right? This is completely one autonomous system. Exactly. So later after, let us check with R2. Okay, 51 and 100. Let us open our notepad first. Okay, 51 and 100. Is that clear? For R2, it is 51 and 100. R2. Yes. For R3, it is 51 and 51. Okay, 51 and 51. Good to go for R3. And for R4, it should be, for R4, it should be 0 and 100. Good to go. And for R5, it is 0 and 51. For R5, it is 0 and 51. Good to go. 0 and 51. And now let us check with this command from R1. Okay, let us check from this command from R1. Fewer times what happens, this designated router will behave as a border designated router. Don't worry about that. Don't worry about that. I mean, backup designated router. It will act as a, both will act as a backup designated router. Exactly. Both will act as a backup designated router. Few instances, it happens. Is that clear, guys? Okay. So what is the neighbor ID? First of all, the neighbor ID is what? How the neighbor ID is selected? So which are the neighbors, guys? Which are the neighbors of R1 now? Please tell me. Which are the neighbors of R1? Which are the neighbors of R1? R2 and R4. Exactly. Very good. Exactly. R2 and R4. So R2 has got two interfaces, na? R1 has also got two interfaces, na? Yes. So among these interfaces, R2 is configured with 70 network and also it is configured with 60 network. Yes or no? Yes. R4 is configured with 80 network and it is configured with 90 network, if I'm not wrong. Yes or no? 80 and 90? Yes. So out of this, which is the bigger value, it will be taken as a router ID. Is that clear? Is that clear for everyone? Outer the bigger value, it will be taken as the router ID. Yes. It will be taken as the router ID. So let us check. Yes. Okay, for R1, R2 and R4 you said, okay, 90 is the bigger one with respect to area 100 and 70 is the bigger one with respect to area 100, which is passing through those interfaces. Yes or no? Let us check with this command. Show OSPF neighbor. Show OSPF neighbor. I'm just checking it. Show IP, sorry. What is that? Show two times. I'll also forget the commands. OSPF neighbor. OSPF neighbor. Okay, see, as I said, the backup designated router, can you see here? Both are behaving as a backup designated router. So it is also a good practice, no issues. It is also a good practice. Can you see that? Am I audible, guys? Yes. See, which is the IDs which are chosen? The largest IDs are chosen, right? For neighbor ID. 60 will not be chosen because 60 is not the largest ID, right? 60 will not be chosen because 60 is with respect to area 51. See, 60 is with respect to area 51. Which is the neighbor ID? FA0 bar 0, it is 70, right? 70 is chosen. I mean, after 70 for R1, there is one more ID, right? For R4. R4 has got two interfaces now. 80 and 90. So out of 80 and 90, 90 is the greatest. So that will be elected as a highest ID. Exactly. That will be elected as a highest ID. Yes. Clear? Okay. Let me check for R2 as well. Show IP OSPF neighbor. Okay. Please cross verify this. See the state. Okay. I'll just go to. Okay. See 60 and 80. Do you agree? 60 and 80. Yes. 60 and 80 is there. No? Then show for R3. Show IP OSPF neighbor. So 70 and 90. 70 and 90 is there. So let me check the IDs. Okay. Let me check the IDs. 70 and 90. For R3. Is that the same IP address? Yes or no? For R3? Because it is R5's area 0. R5's area 0 is also popping up. Yes or no, guys? With designated router. And 90 is given as a backup designated router. No issues. Whether it is DR or BDR, no issues. Don't worry about that. Okay? Yes. See, few times in the topologies it happens. Don't worry about that. So I can't give the specific reason on it. Show IP OSPF neighbor. So 90 and 60 for R5. For R5, 90 and 60. Are we good to go? 90 and 60. Check it. 90 and 60. And for R4, it should be 90 and 80. No, it is 90 and 80. It is 90 and 80. See, for R4, it is giving exact value, right? Designated router. R4 is a designated router, na? It is giving for both the interfaces or for both the areas, it is a designated router. It is providing. Yes. So now, which is the next command? Show IP protocol. Let us check with one router and we'll go across. Show IP protocol. Can you see the default value, guys? The default administrative value, it is 110. Okay, are we getting, so what is the router ID? It should be 80. The router ID should be 80. Let me check whether, yes, the router ID is 80.0.0.1. Clear? Clear with this concept? And what is the process ID? It is up to OSPF1. Exactly. It is up to OSPF1. Next. Show IP Pro. Okay. Give it in all the region, and for area 0 also we'll check it. For area 0, let us go with this one. Show IP protocol. Yes. The same thing, right? All the network has got the same administrative distance. Can you see here? Exactly. Is the same message we are getting here? Yes, 51.0, 51.0, and the values, and when it was last updated and when it was shared. So the same thing. And later after, go with this for R1. Let us go with R1 now. Okay, let us go with R1. Few times the metric value will change with respect to bandwidth. Don't worry about that as well. But it should be 110 always. It should be 110 always. Show IP route. Show IP route OSPF. Okay. Can you see here? So it is what? Inter area. It is configured to inter area. Let me check this. No. Everything is configured to inter area, right? The metric value is being changed. It depends on topology to topology, or it depends on the routers as well. Is that clear, guys? It depends on the routers as well. It depends on the router's interface bandwidth as well. So it will be keep on changing. It is completely dynamic. So don't worry about this. Don't worry about these values, but worry about only this administrative distance. Is that clear for everyone? So why it is subnetted? Can you please tell me why it is subnetted? Why it is subnetted? What is the concept of subnetting? What is the concept of subnetting? That is conversion of classful to classless, right? Conversion of classful to classless. Exactly. Conversion of classful to classless to decrease the wastage. Exactly. To decrease the wastage. Yes. So it has been subnetted. Let me check the output. There are too many interfaces. Okay, let me check the output. Is this the same output we got? Check it. Don't worry about the interfaces because here they have taken some other interfaces. Don't worry about the interfaces here. Just worry about only the output. For reaching 11, we are passing through 80, right? To reach destination 90, it is taking shortest distance. So how it is calculating the shortest distance? How it is calculating, guys? Whether it is calculating the shortest distance or not? Okay, where is 11? It is in area 51, right? 11 is in area 51. Do you agree or not? 11 is in area 51. Now, even area 100 update is also been updated in R1, right? Area 51 is completely remote for R1. Do you agree? Area 51, it's completely remote for R1. Even though there is an exchange. How the exchanges are taking place? Because of R2. Are you getting cleared? Because of R2, R1 database is being updated now. If the concept is clear. Yes. Whomever the neighbor who is trying to exchange that information, that neighbor is not visible here. Can you see here? Is 70 network is visible here? The directly attached network, whether it is visible here? No. Why? Because he is the one, he is sharing his other interface details with him, right? With R1. So where is 60 network? 60 network is mutual for R2 and R3. Yes or no? 16 network is mutual for R2 and R3. So by this interface information, he is trying to share that information with his neighbor R1. Are you getting the concepts? Yes. Okay, good. Now let us go with show IP root OSPF in this table. The same thing. Let us check. Okay. So this is what this is what the difference I was expecting. Let us go with this difference now. Okay. Let us go with this difference. Where is R1? Just close this R1. Okay. Can you see R2 stable now? Yeah. Can you see R2 stable? Whether it is inter area or only OSPF has been updated. Why it is so? Why all the OSPF messages are not triggering with inter area? Tell me the reason. I think by this time you should be able to address it. Why only 90 network is popping up with inter area? Yes, it is connected to both the areas, right? It is connected to both the areas, but that particular area only. It belongs to that particular area only. So that is why it is not popping up with these two networks. Apart from these two networks, it is popping up with 90 network. Can you see here? Can you see here? Yes, exactly. The same thing, right? Same thing. Don't worry about the exact IP address. They are configured with different interface addresses, and we are configured with. Worry about only the network part. Worry only with the network part. Clear? Okay. Let me check with one of the router which is having area 0. Show IP root OSPF. Okay, show IP root OSPF. See, as it is a backup and as well as a designated router, so it should be configured with two inter areas. Yes or no? It should be designated with two inter areas. Yes or no? Yes, because see, to reach 60, it is taking via 90. So how many possible ways it has got to reach 60? Tell me, guys, how many possible ways are there? So I'll just show you the same topology. I'll show you. So this is one router, this is one router, and this is one router, and router 4 is here, and router 5 is here, right? So to reach 60 network is here, right? Do you agree? 60 network is there. Yes, exactly. Now where is router 4? Okay. To reach that 60 network, it is taking what? It is taking via 90. Where is 90? 90 is here, 80 is here, and 70 is here. Yes or no? 11 is here. 11 is here. So how many hops it requires? Tell me, how many hops it requires? 2 hops, right? Even for this route and this route as well, it requires 2 hops. Either the hops it is taking, that's it. Either the hops it is taking, which has got highest ID. Is that clear, guys? Which has got the highest ID. Got the concept? It is taking, of course, it has got equal hops. To reach network 60, it has got equal hops. You got the concept? But which is the route it is taking? Which has got higher bandwidth with appropriate higher IP address. Is that clear? Yes. Let me check here with one more network. 11.0. Where is 11.0? 11.0 is here, right? It can reach 1, 2, 3, 4. But here only one hop is required, right? So when hop comes in between, hop will take the maximum privilege than the ID value. Is that clear, guys? Do you want me to repeat it? Do you want me to repeat? Okay. See, we are in router 4. Now router 4 want to reach 60 network. Router 4 want to reach 60 network. To reach 60 network, what it is planning? It is not planning either by this way. It is not choosing the exit interface of 80. It is choosing the exit interface of 90. Why? Because 90 has got the highest privilege, right? Highest ID number. Yes. So it is trying to reach the 16 network by having the highest network ID value. Clear? And also higher band. Exactly. Got the concept? So now we are efficient to work on it, right? For multi-area, it's easy. Is it easier? Yes. It's easier. Only when you work. That's it. Only thing is you have to work. Then only it will be easy. Concept is clear, na? Yes. Yes. Okay. Now, which are the important commands that are required? Please tell me. Important commands of OSPF. Show IP Pro. Show IP Pro. Show IP Pro. Then what state? Link state. Link state is nothing but the immediately attached neighbor. That's it. It advertises the information. So till now, that is what we saw it, right? Show IP root OSPF, and then next one is show IP OSPF neighbor. OSPF neighbor. Any other commands I have missed out? Show IP interface brief. So it is very standard. And again, you can also check with show IP root as well. Clear? Clear with this? Yes. Okay. Are we good to go with the next concept? Sir, what is meant? Designated router is nothing but the router which is attached to default area. Is that clear? The router which is attached to default area that represents, that is one condition which is attached to the default area, and also which acts as a higher preference, on that network is nothing but designated router. See, whatever the things I have explained to you, please keep those things only. Can a designated router? Yes, designated router can also act as a backup BDR. Designated router can also act as a BDR. Yes. And in Lex, you got many other videos as well. You can refer to that videos as well. No issues. Welcome, very welcome. No issues. Okay. Are we good to go with the next concept? Do you want a pause? Do you want a pause or you want to continue? Oh, I'm getting a few things here. What is that? No, I just missed that. What was the question you asked? I just missed some question. It popped up and it went. Can you repeat the question? I think it was it Chetan? No, it is not popping up here. Why? It's displaying that it is going off. It's happening, so 1 second, guys. Just leaving it. Screen is stuck. That's why. Are you able to see my cursor? Are you able to see my cursor? No? What was the question? How about now, guys? Are you able to see now? Yes. What was the question? Okay, well, let me open. Can you please repeat the question? It popped up and it is getting, it is not displaying. Can you repeat the question now? I'll just stop sharing the screen and I'll just come back. Because I opened two windows now. We have two WebEx sessions now. There's some problem with that. Where is it? In the chat box? Screen also needs break. No, something like that. Okay. Oh, no, I'm able to find it now. 1 second. Okay, to delete, right? To delete, you can, okay, to delete. Okay, it was Chetan, exactly. I thought it was Chetan itself. Fine, Chetan. Chetan, to delete it, this is the command. Are you able to see my window? Use the command clear IP OSPF. Clear IP OSPF. Got it? Clear IP OSPF to delete the OSPF route. So it need to be given in privilege mode. In privilege mode, especially. Okay, in privilege mode. Got it? I think this was the question that you asked. If I'm not wrong, Chetan. Was the question? Yes. Okay. Well, you want me to unmute? Okay, 1 second. Okay. You can unmute yourself. You can unmute.
Hello, sir.
Yes, Chetan.
Sir, yesterday we have used that no root RIP for deleting the root of RIP protocols, which was told by Ganesh. So I thought that here also we can use no root OSPF to delete
clear IP OSPF.
Clear IP OSPF.
Yes.
Okay, because if some mistakes will happen, then it will be very difficult to do everything again, or it will overlap.
Notepad. That is why you use Notepad. That's it.
Yes.
Because Notepad is editable, but in CLI mode you can't edit it, right? So
Yes, that's
if you are having the documentation in the Notepad, it is very easier and it will give you faster run to execute the
And sir,
command.
if while configuring the IP addresses, if you want to change the IP address, then we can use no IP address command. Because I searched yesterday on Google, there was a command that no IP address.
You can use, or you can shut down the interface and you can restart the interface.
Okay. Means by using SH.
Yes.
Sir, suppose we use SH command, then it will delete all the IP addresses given to that particular interface.
See, SH command works only when you are there in that respective interface. Got it?
Yes.
SH command always, SH or no SH, it will work only
yes,
when
we have
you
to
are
use int and interface name.
Yes.
Okay, fine. Thank you.
No need of using the interface name. See, the SH command always works. The SH command always works only when you are there in that interface.
Yes, sir. I know.
SH command, of course, the interface will automatically become shut.
Yes. But after shutting, it will delete all the IPs respected to that interface, no?
No. The only administratively it will be down, and later after you can change that IP address. No issues.
So it will not overlap, na? Then after that.
No, it will not overlap. It will not. It will change. I did it many times, no?
Yes.
Yes, you can do it. No issues.
Okay, sir. Thank you.
Clear with the concept, guys? Clear? What is the difference between O and OAI? OAI is nothing. IA is nothing but inter area. O is nothing but the total topology of OSPF configuration with respect to that route. inter area, and we saw that diagram, right? Internal routers. Yes or no? It is an inter area. If the router is if the router's interface is belonging to only one area, then it will give us inter area. Clear?
Hello, sir.
Yes.
Without deleting what we made a mistake during that command, can we put again that command? Means corrected one. So no need of.
What is your doubt? If you are working on it, can you please show your screen?
No, I'm not working. I'm getting that on. If you did make any mistake during putting that command, after directly we can put corrected one. So
no, you can't.
So for that, no root rib command is there, right?
Again, it will overlap, no? See, Adinath, don't get confused. See, whenever a command is given, always look up with the global configuration mode first. Why we give global configuration mode? It should need to the interface level, right?
Yes.
It should lead to the interface level. Only when you are there in the interface level, then only the trouble happens. If you are out of the interface level, the trouble will not affect. Is that clear? Whether it may be for any of the protocols. See, for configuration of OSPF, did we go with global specification mode or only with global configuration mode? Did we go with global specific or global configuration mode? That is my question.
Global configuration.
We went only with global configuration mode, na? We didn't activate any interfaces, na?
Yes.
Yeah, globally we want it, right? What is global? So that we need to add entire networks which are attached on that topology. Yes or no?
Yes, sir.
Specifically going with that interface, what happens? You will not be able to add the entire network.
Yes, right.
Got it?
Yes, got it.
Yes, exactly.
Thank
you. Yes, guys, are we good to go with the next concept? No, RIP is not there. Summarization, I'll tell you what summarization is all about. I'll tell you. What, Ambika, I didn't get you. What is pause? You need break. What is pause? No, I didn't get you. What you are telling? Practice. You want practice? No, I want to clear with one more thing. Virtual link. We'll go with virtual link, and I'll give you time, ample amount of time. Okay, from 2 at 12:30 you can practice. Is it good? Yeah. So for the same scenario, I think they have created one virtual link. So let us go with that. Anyways, authentication you are familiar with. There is a slight changes in the syntax. Fine. So we'll go with virtual link now. Okay. Can you see the difference, guys? Okay, one second. I'm just share the screen now. Am I audible, people, to you? Am I audible? Okay. Yes. Now, can you see the screen? There is an addition into the topology, right? Because it is not that this network will be completely static all the time, right? I'm not talking about static routing here. I'm talking about the condition or the status of the network. It will not be static, right? It is not permanent. This network, that is only 5 routers are not permanent, right? There will be addition and deletions. Yes or no? Yes. And few networks will be added for a time being. Yes or no? For the temporary, for the permanent structure, there will be few networks which are added to temporary. Yes or no? Yes, exactly. Now, whenever a network is being created, we know the concept that there should be a backup area. Yes or no, guys? Yes or no? There should be a backup area. So what is backup area? It's a default area, right? Backup area is nothing but the default area. Exactly. Default area. So this default area, for an instance, in this particular scenario, and 1 second, I'll just go with some other pen. It's troubling a lot. See, in this scenario, in the earlier scenario, what we came across with, only these routers were there, right? This was there. Yeah, only this router was there, this was there, this was there, and this was there, and this was there, right? Yes. Can you tell me R2 is not directly associated with area 0? Yes or no? Yes or no? Yes, R2 is not directly associated with area 0. But R2 is mutual for the areas which are associated with that area 0, right? Yes, yes or no? I'll give you one beautiful example now. So it's something like sorry for my drawing. Okay, sorry for this drawing. So, okay, treat this as a book, and this is the floor, and this is the table. Fine. It is the worst drawing ever. It's the worst drawing ever. Yeah, 2 legs. Yeah, it can happen. No? Treat that it is a central piece. It's a central piece. Now, 2 legs can be there. Yeah, we want concept. That's it. Exactly. The table is on the floor. Associative law, right? Associative law. The table is on the floor. Which one? Associative or transitive law? Associative or transitive law it is? Associative law, yes, exactly. So it is, the table is on the floor, the book is on the table. So treat that totally, book is on the floor. So there are so many memes on this associative law. Let us stick on with only the table and book. Table is medium. Yes, exactly. So likewise, here also router is associated with area 100 and area 15. So by default, it will be associated with area 0. Right? By default, it is associated with area 0. The book is on the table is on the floor. So totally book is on the floor. Something like that. Yes. So based on this condition, see here, there is an additional network which is being added. Can you witness this? There is an additional network. So this additional network is not directly attached to area 0, right? So which is the router which will be acted as a designated router here? Which is the R3, exactly. Very good, very good. R3 is the designated router here for this area. But R3 whether R3 is associated with area 0? Yes, it is associated with area 0 because R5 is representing area 0. Exactly. R5 is representing area 0. So R3 is also associated with area 0. Now tell me who is the mutual area for area 10 and area 0? Who? Yes, exactly. So now we need to take the lead accordingly. That is area 51 will be area. No, I'm not talking about the IP address, people. I'm talking about the area. Area 51 is mutual for area 10 and area 0. Now, can you say that according to the definition, what should be the definition? In a OSPF network, there should be at least one area, right? At least one backup area or default area should be there, right? Did we achieve this? Did we achieve this area? By taking the mutuality of 51, did we achieve that statement? Yes or no? Yes, there is a associativity that exists between the areas. So it doesn't only serve the purpose. We need to R6 also indirectly connected to area 0, of course. But to indirectly connect that area 0, we need to create a virtual link. As you said, it is indirect. Right? As you said, you said indirect. We need to create a virtual link on that interface. So what is that virtual link? Here we go. Got the concept? Got the concept, guys? Yes. So let us try to configure that concept. I'll just give the explanation over the legs and let us try to configure that concept. Clear with the definition? I'll show you which interface I'll show you which interfaces are to be turned for this one. I'll tell you. Now R6 is, for R3 also we need two interfaces, right? For R3 we need two interfaces, na? Yes. For R3 we need two interfaces. Okay, let me open the notepad and let us go back to R3. Where is R3? R3 is here. Okay, R3 is here. And what I do is, I'll just paste this, which is the interface 1/0. And what is the address given there? 40, na? It is a 40 network. 40.0.0.1. Exactly. And here I'll give network 40.0.0.0 0.0.0.255. What is the area? Associated area? Area 10. Exactly. Associated area is area 10. Exactly. And
sir, this is for virtual link creation, no?
Yeah, this is for virtual link creation.
Sir, can you please show simultaneously both the things, notepad and that diagram? I need to see that 1/0 and in diagram.
No, 1/0, it is not available. 1/0, na? Okay.
Yes, you have taken 1/0. It should be 0/1, no, sir? Exit interface.
No. Not exit. Don't mix up exit interface. Don't bring the nomenclature exit interface here.
Okay, fine.
Okay.
It's going through 1/0. Yes.
Don't mix up. Yes. Don't ever say that exit interface. There is no concept of exit interface here.
Yes, okay, fine.
Okay. So this is the ID I have created with respect to this interface, if I'm not wrong. Okay.
Yes, sir.
Okay. So let us create R6. Let us create R6. So R6 with respect to FA 0/0. Let us create it with respect to FA 0/0, and it is 2. And also let us keep as it. Let us not create the OSPF configuration. Okay, if it is required, let us create. Okay, once again, conf t, because I need to show that explanation. Conf t network router OSPF process ID should be what? 6. OSPF 6 network 40.0.0.0 0.0.0.255, and it is area 10. Exactly right? It is area 10. Okay. So the things are done now, right? The things are done, and we'll just go back to the legs. We shall go back to the legs, and we shall see, as discussed, every area should be connected to backbone area. Yes or no?
Sir,
According
it should be of 0/1 na, for R6.
No. I'll configure it for 0/0. Don't worry as of now. I'll configure it for 0/0 only. They have taken 0/1. Wow. Is there any condition that we have to take only 0/1? They have taken 0/1. I'll take
Yes.
0/0.
Yes, fine.
Okay. Yes. It's a Lex interface. They have configured. Someone has configured and they have done it. It is also holds good. No issues. You can do it accordingly. Okay. So let us once again. Chetan, don't interfere in between 1 second, please. Don't mistake me. Yeah. So, however, there might be a case where in normal areas, non-backbone areas also exist, na? Non-backbone areas. Which is the non-backbone area? How many non-backbone areas are there in this? 100 is there, 51 is there, and area 10 is also, right? Area 10 also. According to the situation, area 10 as well. Next. Cannot connect to backbone area directly as shown in the topology. Exactly. Next, a given topology, area 10 is not directly connected with area 0, as I said. Guys, what do you want to mute all? Okay, sorry. Are you getting it? Now, yes. Thus, the routing table of area 10 will not be propagated to the other area routes as it is not directly connected to backbone area. To solve this issue, we can use virtual link. Virtual link in which area? Virtual link in which area? Virtual link should be used in which area? Area 10 or area 51? It should be used in area 51. As I already said that area 51 is mutual to 0 and 10. Right? Area 51 is mutual to 51 and 10. Exactly. So we shall use that. Okay. So virtual links acts as a bridge between backbone area and the other area which is not able to connect to the backbone area. You need to establish virtual link between area 0 and 10 as highlighted in the following topology. So where it has been interfaced? It has been interfaced between R3 and R5. So where we need to create the virtual link now? It should be created between R3 and R5. Is that concept is clear? Why we are creating? Because it is mutual for backbone area and the additional added area. Additionally added area, it is mutual. So that is why we are creating the virtual link between those earlier areas which are mutual. Is that clear? Now, what is the syntax? What is the syntax? Router, OSPF, and process ID. What is the process ID? Let me check. Don't worry. Let me check it. And again, area ID, virtual link, router ID of the neighbor router. We'll see what should be the elected router ID of the neighbor router. It should be the highest ID. Let me see that. Okay. So let us configure virtual link between R5 and R3. Are we good to go to establish virtual link between R5 and R3? Yes. Okay. So yeah, same thing. Interfaces been assigned with the IP address, but in R3, can you see here? In R3, did we did this? Have we taken care of this? Have we taken care. Without configuring this IP address, you will not be able to configure the virtual link. Is that clear? Because it is also need to be added on that network, right? Yes, it should be configured. Yes, configure R5. R5 doesn't require. R6 also fine. So now configure R6. R6 also we have done it. Okay, done. So where is virtual link? Okay, can you see here? Did we did this? Did we added this area? Yes, we have added this area and later on we'll paste it into the terminal. Did we did this for R6? Did we did this with process ID? Yes, OSPF process ID and the network we have added. Only one network is there, right? So only one network can be added. So this is what, and next one. Anyways, this is the same thing, the same table which we have discussed earlier. Next. Where is virtual link? So how to process with the virtual link I'm showing. Okay. Let us go back to the virtual link, which is the area. 51 is the area, right? 51 is the area. We shall go back to the interface of R3 command prompt, and we'll delete. Okay. So before that, you need to add the IP address which we have added for the configuration. So which is this? Okay, fine. Router OSPF 3, fine. So let me add the. Okay, it is not taking. One second. Because we need to add this first. So the address assignment also should be added. Do you agree? Why it is not taking? Yeah. Okay. So we did a mistake. One second. Treating that, yeah, in the topology, we are not added the router at all. See, how silly mistakes. Yes, how silly mistakes are done. It's R6 is added. Okay, no issues. Fine, I'll just stop this topology now. So if I stop this topology, and I don't think so. We have saved the configuration, right, in all the routers. I'll stop anyways. Okay, I need to add one more slot to this router. Okay. So this is, which area is this, guys? Area 10. Agreed? This is area 10. So now what we do is we'll just go back and we'll just turn it on and we'll just go back. I was wondering why this is not accepting. Okay. So that was the issue. Again, it restarted. So many time it will kill. That is the issue. Think that if you are not configured with the notepad, let me check show IP interface brief. No, once again. Okay, all the addresses are assigned right and up and running. Okay, I'll just add. Okay, it is added. Now it is added. Okay. Show IP interface brief. Okay, all the networks are added here. And let me add the OSPF configuration again because it will reboot. Oh my god. Yes. What is true, Vikas? What is that message? Show IP root OSPF. Let me check. Oh. Show IP root OSPF. Okay, it is not added because we need to configure R6. Let us go to R6. Area 10 is added. Exit. Do show IP router. Is directly connected to 40 network. Okay. Now go to R3. Now go to R3. Go back to R3 and start doing the process. So we are in R3, right? So what are the things that we need to take care? Enter into the global configuration mode. So once you enter into the global configuration mode, provide this content of R3, OSPF3, and to establish the virtual link. So the configuration what we are dealing here is establishing the virtual link. So area, so which is the area mutual area, it is 51. Is it 51? Yes. Next, provide virtual link, which is the router ID. Which is the router ID to be configured? Neighbor router ID, right? Do you agree with that? There was something like router ID of the neighbor, right? So which is the router ID of the neighbor? Is it 11? Because maximum ID, I told it right. Who is the neighbor of 3? Who is the neighbor of 3? R5 na? With area 51. R5 and R2 both are there. R5 and R2 both are there. But who is having the maximum ID? R5 na? R5. So what is the maximum ID of R5? 90.0.0.1. Exactly. Let me check. So let us not create confusions here. Let me check with R5. What is the ID of R5? Show IP interface brief. See, can you see this? Can you see that? A neighboring router ID with maximum value. Exactly. Router ID, whenever the concept of router ID comes into picture, you should be very familiar that the maximum should be taken care. Clear guys? R5. Okay, fine. R3 we are dealing with. 90.1.1. Okay, 0.0.1. Exactly. Next, exit. So, WR. So, the configuration is saved. Next, go to R5. Next, visit R5. And process accordingly. Configuration terminal. So, which is the process ID? OSPF 5 area. So area will be similar. Virtual link. So which is the ID we need to consider? Neighbor's ID, right? Neighbor ID which is mutual for area 51. This is R3's. Yes or no? This is R3 ID. So what is the R3 ID? Let me check this again. What is R3's ID? We configure for R3 or R4? Let me choose everything. R3, right? Show IP interface brief. So what is the ID? The maximum ID of R3, which is connected to area 51 is 60.0.2. So here they have taken 1, but according to our scenario, we should lead with which one? According to our scenario, we should lead with which one? They have taken 60.0.0.1, but in our scenario, it is 60.0.0.2 exactly. And exit. And WR. Okay. Now, verify the virtual link now. Now go to R3, show IP OSPF neighbor. Okay. What it is providing? It is not providing any routes. Okay, once again. So it is R5 I'm talking about. Okay, this is R5. Let us take R3. Show IP OSPF neighbor. Yes. Are we connected with this network now? Yes, are we connected with this network? Yes, guys? Did we? Yes. I think you got the concept. How virtually the network is connected, even though if it is isolated with area, default area. Is the concept is clear? Is the concept is clear to everyone? Yes. Yeah, you can check accordingly and you can work out with the network. And at 1 o'clock, you can take the break. I'll repeat it. I'll repeat it. After the break, I'll repeat it. Once again, I'll give you a glance. I'll repeat it. 1 o'clock, you can take the break and you can start working now. Yeah, 1 o'clock, please take the break. Don't leave the meeting till 1 o'clock. 1 to 2:30. 1 to 2:30. 1 to 2:30 will be the break. You can take the break. Okay. Thank you. You start working now. Don't leave the meeting. At 2:30 till 1 o'clock, you have to work and you can leave. Clear? Okay.
Tala, I mean, what is this, Basha? What is the issue? What is the issue? Lab on cloud. You need to book the slot. That is what I told you, right? You need to book the slot. You registered it. Okay, okay, fine. You registered it. Can you please share your screen? Yes, Basha, can you please share your screen? Okay, we'll look into this, Basha, and after this. After this, we'll look into it, okay? Please open. No, no, Basha, please. I'm just telling you that navigate to the next step. We'll look into it. Yes. Please open the lab on cloud and go for your respective booking slot. Yes. So which is the booking slot? Where is it? Where is it? Please tell me where is it? Okay. Next one. Your screen is not appearing, Basha. Your screen is not appearing, Basha. Is it visible? Oh, yes. Who is this? Hello. Hello. No, I am not able to view your screen. Can you please stop sharing your screen and do it again? Okay, we shall check it, Basha. No, we shall check it on the after the break. No, don't worry. I'll check it.
Okay, guys, let us take lunch break now till 2:30.